Up now, we have Matt Jarvis, the Director of Community from our friends at D2IQ. So let me pull Matt into the stream. There we are. Hey, Matt, how's it going?
Good, thank you. It's a bit early for conference talks, but...
Say again?
It's a little bit early for standard conference talks.
So whereabouts are you calling in from today, Matt?
I'm in the Lake District in the UK.
Oh, beautiful, lovely. So you must have been beautiful there over this last weekend or so with the nice sun.
It's been very nice indeed.
Excellent. Well, welcome to all the talks, Matt. It's great to have you. So Matt, you're the Senior Director of Community and Evangelism. So what does that mean?
I'm responsible for all our worldwide developer advocacy and evangelism programs, and also for strategy around how we consume and contribute to open source.
Awesome. And briefly, what does D2IQ do? What do they do in the community, and what do they do in terms of a business? So
D2IQ, some of you may be more familiar with our previous name, Mesosphere. So we've been around in the container space for a very long time, around Apache Mesos to start with. The company was actually created by one of the founders of Apache Mesos. And, over the last few years, we have also diversified into products around Kubernetes and the cloud native ecosystem.
Awesome. And today we're going to be talking about Kubernetes Operators the easy way, introducing KUDO. So without further ado, Matt, I'll pass over to you because I know we're short on time. So you have the helm.
Thank you, Simon. Good morning, folks. Let's just cue this up. So this is me, Matt Jarvis, Director of Community at D2IQ. And just to set the scene for what we're going to be talking about today, so Kubernetes and other orchestration systems built around the idea of declarative state work very well for stateless applications. So a stateless app, as many of us will know, is a program that doesn't save client data generated in one session for use in the next session with that client. So every session is carried out as if it was the first time, and responses aren't dependent upon data from that previous session. In practice, what this means is that we can generally start and stop our stateless application. It will just start executing. So in general, we run this kind of application behind a load balancer, and we can scale these up, scale these down just by adding or removing instances. And we can also deploy new versions pretty easily by simply replacing all of the running instances. And we can have various ordering strategies for performing these tasks, blue-green deployments for testing new versions. But fundamentally, the management of them is pretty much binary. We're either running or we're not. And stateless apps are kind of intrinsically intertwined in the move towards microservices architectures, where we connect together many very simple applications which each have a particular well-bounded function. And I guess to the adoption of container technologies to manage them, because they're fundamentally well suited to the patterns that systems like Kubernetes give us. We just declare that we want a specific number of an application to exist, and Kubernetes will create them for us. And again, it's basically this idea of a binary process, either running or we're not, and we don't have to worry about any complex operations to configure them before we start deploying. So if all our applications were stateless, then the world of application deployment would be super simple. And sometimes in our industry, you could get the idea that that's the case in the era of microservices. But unfortunately, that's not actually true. The second class of applications are stateful, where the app's retaining data or state across its entire life cycle. And whilst older, more monolithic applications like SQL databases fit into this paradigm, there are also a lot of architectures where the individual elements making up a particular service are actually clustered together in some way. They might be sharing state data between them, or they need to be synchronized together. And this is a whole area of computer science unto itself, but typically these kinds of applications have a set of lifecycle states that require a logical ordering of actions in order to maintain operation. In general, we can't just stop and start instances and expect the overall service to continue to operate. We might need to wait for rebalancing of data, or there might be multiple steps involved in an upgrade operation. And that applies not just to upgrades, but it applies to scaling, to failure scenarios. And these operational strategies require domain-specific knowledge to manage them. So they tend to be unique to the application. Those operations for a Cassandra cluster, for example, are different from a Kafka cluster. And Kubernetes was originally very focused on stateless application architecture. One of the fundamental features of Kubernetes is that the scheduler can move pods around between agents, which works fine for stateless applications, but not so well for stateful, which tend to like their storage and networking not to change during operation unless we handle them in a very specific operational way. So in order to try to handle the complexities of stateful apps, Kubernetes added this concept of stateful sets, which does give us this idea of stable network, stable storage. But this still doesn't really solve all our problems, because Kubernetes still doesn't know what's actually going on inside pods, inside our applications. So the emerging solution over the last couple of years to this problem is the operator pattern. Operators basically encapsulate operational tasks in code. We can either run those via APIs, we can run them automatically or scheduled. So we can orchestrate application-specific lifecycle actions using Kubernetes APIs. So those operators encode domain-specific knowledge about the lifecycle actions required for an application. How do I scale it? How do I upgrade it? How do I deal with failure scenarios? And they achieve all of that using native Kubernetes APIs. So what are operators? Well, when we install an operator, we like to get the operator itself, the controller, that's the code that manages the life cycle of that particular thing. And this is where that domain-specific knowledge is encapsulated. And we'll also likely get a bunch of custom resource definitions, CRDs, which extend the Kubernetes API to address new resource types. So you can then put data into those types and instantiate them. But in general, these have been unique, so the operator has been purpose-built for each application. And there have been two main ways of building operators. There are a bunch of other ones, but the first one's the operator framework. This originated at CoreOS, mainly developed by Red Hat and by IBM. And whilst you can build operators using Ansible or Helm charts, there is also a Go SDK. And for complex operators, you really need to build using that Go SDK. And then there's the KubeBuilder project, and that's part of SIG API machinery. And that's focused on extending the Kubernetes API. And again, you need to write a lot of Go to build operators using this. So building operators can be very complex and requires a lot of knowledge about the internals of Kubernetes, requires Go expertise, as well as requiring that domain-specific knowledge about your application. And the engineering effort, which goes into high-quality operators, can be very considerable. So as an example, one of the major NoSQL vendors has an operator that's very feature-rich, but it's over 40,000 lines of code and took more than 1 man-year of effort to write. And even something like the etcd operator, which is etcd has a fairly simple set of lifecycle states, has got around 9,000 lines of code. So KUDO takes a slightly different approach. KUDO is an acronym for the Kubernetes Universal Declarative Operator. And rather than implementing a custom operator for each application, KUDO provides a universal operator with the concept of plans built into it, which allows operator developers to define a lot of the code declaratively in YAML. So it basically kind of defines this framework for operational sequencing and actioning, and allows you to define runbooks and ship that with your application. It's a fully open source project, licensed under Apache 2, and we're actively working to build community around it. And in comparison to those other ways of building operators, then, KUDO's polymorphic, so it will become an operator for any application for which you write a KUDO operator. So it has a single controller, and it can create pretty complete operators without needing either deep knowledge of Kubernetes or necessarily writing any code. So there's some core concepts that we need to understand when we talk about what KUDO is. Firstly, in KUDO terminology, an operator is the the description of a deployable service represented as a CRD object in your cluster. And then secondly, we've got this idea of operator version, and this represents the particular implementation of an operator, and it contains all the objects, parameters, plans, and stuff that you need for that operator, and we'll look at that a little bit in the demo. So the purpose of the operator version really is to provide all the details necessary for KUDO to become an operator for a specific capability, and also for a particular version of that software. So it's a specific version of a deployable application, including configuration and lifecycle hooks for anything you want to do, deployments, upgrades, rollbacks. It's a complete definition of the application to be installed with parameters that we can override. And then the instance is the CRD, which ties a particular application instantiation to an operator version. So this is an actual deployment of the thing we're controlling using KUDO. And when you create an instance, you provide or override parameters that were in the operator version. And we can have multiple instances in an operator version in our cluster. And this is so that we can run different versions of particular applications that we're running. So plans are kind of the core concept of how KUDO operators convey progress through service management operations, like deployment, like scaling, like upgrading. A plan's composed of phases, and these contain steps, and these in turn are made up of tasks. So plans orchestrate tasks through phases and steps. Both phases and steps can be configured with an execution strategy, either serial or parallel. KUDO also includes a CLI extension to kubectl, which allows us to run KUDO-specific commands natively in kubectl, and we'll look at some of those in the demo. So this is a high-level architecture diagram of what KUDO looks like in practice. So we have our KUDO controller deployed into our cluster with a set of default KUDO CRDs. We have our KUDO CLI extension to kubectl, and then we can get operators either from the upstream GitHub repository or from our local file system, and then installed into our cluster there, we can see we've got the Kafka operator with two different Kafka versions in operator version CRDs, and then an instance of one of those operators. Right, so let's look at what this looks like in practice. Let's just change this over. Okay. Are we seeing that window there? Ah, there we go. Okay, cool. Right, so I've got a checkout of the upstream GitHub repository. So let's just take a look at what one of these operators looks like. And this is the Zookeeper operator. This is a fairly straightforward one. And these KUDO operators all have this standardized layout. So at the top level here, we have our operator YAML. And in here, we can see that we've got all our versions. We've also got our task definitions with the resources that apply to that particular task. So these resources here will be applied when that task is applied. And then we also have our plan definitions here. And we can see for the particular step, for this deploy step, we can see what tasks are going to be deployed, are going to be executed for that deploy step. So this is just an empty Kubernetes cluster that I deployed earlier. And at this point, if we look for whether we've got any operators here, our cluster actually doesn't even know what an operator is. So the first thing that we're going to do is to install KUDO, and KUDO gives us a very nice shortcut to do this in KUDO init through our CLI extension. And now if we take a look at what CRDs we've got deployed into our cluster, we can see that we've got our standard KUDO CRDs have been deployed as part of that init process. And we've also got a bunch of API resources that are in the API group of KUDO.dev. And we can see that we've got our KUDO controller manager pod running namespaced in the KUDO system namespace. So the first thing I'm going to go ahead and do here is to install a Zookeeper cluster. I'm just going to use the defaults here from the upstream repository. So when I call KUDO install like this, it's just going to install the Zookeeper operator from the upstream repository. And let's take a look at some of the things that we can do with the CLI extension. So I can look at which plans that package has, and these are the same that we looked at when we looked at the checkout of the actual operator. This hasn't quite kicked off yet. There we go. So we can now see that our deploy plan is starting, and we can see what which phase and steps that's actually executing. And if we describe that instance, we can see that we get a bunch of plan-related information in our describe output here, as well as a lot of metadata about what's actually happening there. And if we start to look at our pods, we should see that we've got our Zookeeper pods are now up and running. And I know that this operator, one of the elements of this operator is a stateful set of 3 instances of a Zookeeper cluster. So now if we get operators, our cluster knows about what operators are, and we can also see that we have a Zookeeper operator installed there. And we can see that we have a Zookeeper-0.3.0 operator version. And if we describe the operator version, what we can see here is that there is a ton of things that are contained within that CRD. And that's basically all of the things that were defined in our operator on disk. So in our params file, we can see that these are all the parameters which this operator sets defaults for and allows you to override. And then if we look in our templates folder, we can see that these YAML files contain parameters that are templated, so that KUDO, when it runs these YAML files, will interpret those parameters as per configuration. So let's just see what status our Zookeeper cluster is at now. So that's almost complete. That's just validating, excuse me. So our Zookeeper deployment phase is now complete. So the next thing that we're going to go and do is install a Kafka cluster, which depends on that Zookeeper cluster. So I'm going to do this one slightly differently. So I'm going to install the operator itself for Kafka, but I'm not going to actually create an instance of it. So that's put the Kafka operator into our cluster. And this is the operator out of the upstream repository. So we can see it's fairly straightforward. It's not got very much configuration there. So what I'm going to go and install a newer version of that from my Git checkout. So now when I'm in this Git checkout, what I can do here is list, that was the same command that I just run against the repository. I'm now running against my local checkout. And you can see in this version of the Kafka operator, there's a lot more configuration options, a lot more plans and tasks. And I can also do the same with tasks. So I can list the tasks that are available from this local Git checkout. And I can do the same with parameters. So what I'm going to do is, again, use the CLI extension to install a version of this this local Kafka operator. And as we see, we're installing here from this particular checkout. And what I'm doing here is overriding one of the parameters. I could do this using a YAML file, but I'm just going to override it on the command line. And again, we can see from our KUDO CLI extension that our deploy plan is now in progress. If we look at what pods we've got deploying here, we can see that we've got the first pod, which is actually setting up TLS certificates between our Kafka instances. And again, we can describe that describe that instance and see all of that plan status within the describe command. So let's just see what pods we're starting to get deployed there. Just watch that for a second. So what we're expecting to see here any second is for the Kafka instances to start deploying into our cluster. Now that the first stage has run, which was to generate certificates. This is going to take a little bit of time here. And there goes our first Kafka instance starting to deploy. And we've now got a second pod, again, generating TLS certificates for the next Kafka instance, which will start to deploy any second. Here's our second Kafka instance coming up. So while we're waiting for that to deploy, let's just cut back to the presentation, and I'll take you through some of the roadmap for KUDO, and we'll come back to this at the end. Once this is finished, it's going to be a little while. Okay, let's just come out of there. Stop that one. Okay, so we'll come back to that demo in a second. So we have a bunch of stuff on the roadmap. KUDO is changing very rapidly. Here's some of the things that are coming up that are pretty cool. So we've got this idea of dynamic CRDs where we don't have to define all our CRDs at instantiation of KUDO or when we deploy that operator. So these could be created on the fly by an ops person who wants to modify how a particular plan is executed. And there's a bunch of work going on about how we can take existing things like Helm charts and extend those into KUDO operators. There's work going on around looking at candidates for replacing some of the YAML here. Managing these long, complex YAML files can be pretty tiresome. And then one of the new things that's just landed that we saw actually in that Kafka instance is the concept of pipe tasks, where we can create take the output of one task and pipe it into the input of another task. And let me just see how our demo is doing. Okay, that's completed. So let's just switch back to our demo again. Okay, let's switch back. Yeah, that's great. Okay, so now we should have a fully functioning Kafka cluster up and running. So if we now look at the logs in our one of our Kafka pods, we can see that's valid output from a working Kafka cluster. And just to prove that that is working, we can start a shell in our cluster, and then I'm just going to connect to the Kafka metrics port there, and we can see we're getting metrics out of our Kafka cluster. So we effectively deployed to a highly available Kafka cluster and a Zookeeper cluster with a couple of commands using KUDO. So let's just come out of here. Stop this. Slides. Okay, so we're coming up to time here. Let's go back to my slides again. Yeah. Okay, cool. So we'd love more folks to get involved with the development or using of KUDO. So there are a bunch of ways that you can find out more if any of this has been interesting. There's the KUDO website at kudo.dev. The KUDO Builder organization in GitHub has all the code for KUDO, the operators, and everything else in there. The development team all hang out in #KUDO on the Kubernetes Slack. And you can also join a mailing list, which is in the link below, and hopefully these slides will be shared. And we also have a bi-weekly community meeting, which is on Thursdays at 10 a.m. Pacific, although I think we're starting to move that around now to be friendly to more time zones. Thank you for listening, and I'm happy to take any questions.
Awesome, thank you, Matt. We have a couple coming through on Slido. One, I'll break into two. This one, will operator replace Helm for packaging applications?
I think they're kind of two use cases, really. I mean, operators tend to be more about long-running lifecycle actions for more complex distributed apps. So I see there definitely being a place in the ecosystem for both of them. Clearly, Helm is much more widely used than operators are generally at the minute. You know, the operator space is still kind of emerging, but for more complex applications that have more complex lifecycle states and for complex application stacks, I think that's the sweet spot for operators.
Awesome, thank you. And also, for people who are starting out, what are the best tutorials or workshops that people can kind of get hands-on and experiment with?
Yeah, so there's a bunch of stuff on kudo.dev. There's a really good getting started guide. You know, hopefully from the demo here you saw it was pretty straightforward to start actually using these things. But there's a bunch of tutorials and a lot more information about the internals of KUDO if you're interested in digging in and getting involved with the development of it. So check out the website.
Awesome, thank you very much. I think that's pretty much at time now, and those are all the questions that we have. So Matt, thank you very much for the support of all the talks, and thank you for a great session.
Thank you, Simon.
No worries. Have a good rest of the day.